Thank you so much. Just wait a second here. I do not.
The clicker is there.
There we go.
The time, you can see the time over there.
Yep, got it. Thank you. All right, thank you all for coming. My name is Jay Schwerberg. I'm the Director of Engineering at HOSHO, and I'm here to talk about analyzing the smart blockchains. Smart contracts exist on many blockchains today, and they do a lot of the same things on these blockchains, but all of these blockchains are using different technologies and have different implementations that are really optimized for different use cases. Some of them are allowing for complex on-chain functionality that allows you to build very complex applications, things like the P3Ds, the Zethers of the world. Some of them are much simpler, talking about some of the smart asset blockchains that really all you can implement on them are tokens, are assets, or ticker symbols, right? The only thing you need to develop on these chains is a name, an idea, a ticker symbol, maybe a quantity of your token. And all the functionality around minting, issuance, transference is already built on chain in a standardized and uniform manner. I think that complexity is antithetical to security. And at HOSHO, where we are the leaders in the blockchain security space, we believe that there is a certain elegance to simplicity. And using one of these simpler blockchains, something like Stellar or NEM, can actually help you to not only have a more cohesive project, but a more secure one. So like I said earlier, my name is Jay Schwerberg. I'm the Director of Engineering at HOSHO. We are the global leader in blockchain security. Our core competency is really in smart contract auditing, as well as consulting for security within exchanges, blockchain projects. We work with ICOs, we work with gambling platforms, projects large and small who want to deploy their smart contracts on the blockchain. And really our goal at HOSHO is to secure those contracts. Obviously, our forte or our core competency is smart contract auditing. And so because of that, many of the projects that we've worked on have been on the Ethereum blockchain or on forks of the Ethereum blockchain. However, and my CEO would probably get very mad if he heard me say this, I think that many of the projects that are on Ethereum today probably don't belong there. If you only have a token that is very simple and you're only doing transfers and you're only doing a crowd sale or you're only using it to trade, there's no reason to reinvent the wheel every time. There is absolutely no reason that you can't use a chain that has already been designed for your use case. Smart asset blockchains are becoming a thing. I'm also a Cisco certified network associate, routing and switching. Before I got into the blockchain industry, I spent a lot of time in a very highly regulated industry, the gambling and lottery industry, where we were bound by a lot of these standards and regulations that are soon probably coming to blockchain, to be completely honest. I'm one of HOSHO's senior smart contract auditors. At HOSHO, what we do is whenever you bring a smart contract to us for audit, it doesn't go just to one auditor. It goes to our whole auditing team. We collaborate on it, and then it goes to our senior auditors to do a final review and ensure that that smart contract is really secure and that our team hasn't missed anything. I've been working in this field since 2013 and have been involved with cybersecurity for essentially my whole career. And that's why I can say with confidence, complexity is antithetical to security. Knowing what platform is the best one for you to launch on is going to help you have a quicker development time. It's going to help you have a more secure project, and it's going to inspire confidence in your investors and in your community that you have made the right decisions. So before we can talk about what platform you should launch on, we have to establish a foundation. What is a smart contract? What are we referring to when we say this ubiquitous term that we hear every day? Smart contracts were defined in 1995 by Nick Szabo as a set of promises specified in digital form, including protocols within which the parties perform on the other promises. Now that's very wordy and very complex, but to simplify it in modern day, a smart contract is computer code or an application running on top of a blockchain that contains a set of rules under which the parties to that smart contract agree to do business. Right? Very simple. All of us know the concept of a contract. You sign an agreement that says, I'm going to do X, this party is going to do Y, and at that point the transaction is fulfilled. Smart contracts do not differ from that very greatly, except in one instance, or excuse me, for one reason, which is that smart contracts are unbiased. Contracts by nature have to be enforced in a court of law. They have to go in front of a judge. That judge has personal biases. That judge has influence on how your contract is enforced and is able to interpret the spirit of what was meant in the contract versus the letter of the law. Smart contracts have no such ability. Smart contracts are an impartial arbiter, unbiased, and they are going to execute exactly what you write in the code. And so you have to be very careful when you're implementing your projects to make sure that your code is sound and to make sure that the logic path that your code is taking is what you expect it to do. Smart contracts will execute the transaction every time if the requisite conditions are met, and if they're not, they simply won't. Now this term, I like to think that I'm creating a genesis of a new term here, smart blockchains, to set a standard of what we expect that smart blockchains do. I'm talking about any blockchain that gives you the ability to implement functionality above and beyond the native currency of that blockchain, whether it be Ethereum, VeChain, EOS. All of them have a native currency that you can transact and do business in, but all of those blockchains also allow you to not only create tokens or assets or futures or STOs, they also allow you to develop complex applications. There are also smart asset blockchains, which only allow you to create tokens and assets. You can't create complicated dApps. All of these, though, are smart blockchains and give you that flexibility. They are all able to be used as a ledger, storing state on the blockchain. Now, the extent to which they allow you to store that data and what data they allow you to store differs from blockchain to blockchain, but all of them have some sort of storage mechanism on-chain. Smart contracts are typically deployed and executed on the blockchain and execute code in an isolated virtual machine. Now, there are some exceptions to this rule, and I'll get into those a little bit later. Transactions on these blockchains will typically levy a transaction fee on whoever is executing the transaction. Again, there's some very obvious exceptions to this rule. And finally, they all provide an API or RPC interface, allowing the state of your contract and of the chain to be queried and inspected by applications or by third parties. One of the benefits, as well as one of the downfalls of blockchain, is that all this data is public, and you have to be very aware of what data you're putting on chain. So like I said, in about 1994, 1995, Nick Szabo defined smart contracts, and that was really the first time we had ever heard of it. He launched an experimental blockchain called BitGold, which is widely seen as the genesis of Bitcoin. It is also widely rumored that Nick Szabo is Satoshi Nakamoto, but I'm not going to get into the rumor mill here. In 2010, we finally had our first real-world cryptocurrency launch, Bitcoin, the mainnet. Hard to believe that it was only 8 years ago, but it really only was 8 years ago. Bitcoin in and of itself was really the first smart contract, and I'm not talking about script with multi-sig wallets. Bitcoin is, by definition, a application running on a blockchain under which, when certain conditions are met, transactions are executed. Every transaction on the Bitcoin network is a transaction against a smart contract. The only difference is that nobody in here can develop a smart contract and put it directly on Bitcoin. It's already been developed, and it's built into the chain. Having said that, of course, there is script, and there have been sidechain implementations that have gone onto Bitcoin that allow you to develop external smart contracts. But in 2015, we finally saw the first true Turing-complete smart contract blockchain launch with Ethereum. In that same year, the first smart asset blockchains launched on their mainnet, NEM and Stellar. In fact, NEM, I believe, is here. That was really the genesis of when people started realizing that blockchains could be leveraged as more than just cryptocurrency machines. You could actually start to build complex applications and launch them onto networks. In 2016, AntShares, now known as Neo, launched. They are another smart contract blockchain, that allows you to build complex applications. In 2017, we really saw the influx of the enterprise blockchain with IBM launching their Hyperledger platform, allowing traditional developers to very quickly and easily spin up blockchain projects that are permissioned, that are within their own space. We also saw the first sidechain for smart contracts that has hit the mainstream, also here at the conference, Rootstock. A sidechain for Bitcoin that uses Solidity and a lot of the same mechanisms as the Ethereum blockchain to transact in smart contracts. And then finally, just this year in 2018, EOS and VeChain have both really taken the limelight. EOS, I'm sure everyone here is familiar with. They unfortunately don't seem to be able to stay out of the news. And VeChain is an Ethereum fork that also has gained a lot of popularity, though definitely less infamous than EOS. So let's start with the genesis. Ethereum, the first real smart contract blockchain and the first Turing-complete smart contract platform. Smart contract code is compiled to Ethereum bytecode, executed on chain. It is a Turing-complete language, meaning that you can do basically anything, which is both a benefit and a downfall to the chain. There are no standards and no, I guess, standardized or uniform behavior enforced by the blockchain, other than the fact that the code will always operate the same way once you write it. Standards are really developed and maintained by the Ethereum community, approved by the Ethereum Foundation, but it's on the developer to, it's on the developer to actually implement these standards correctly. ERC20, ERC223, ERC721, ERC with any random 3 to 4 number code after it. They all exist and they work, but if you don't implement it correctly, there is no guarantee that those are going to execute correctly on chain. Shameless plug, if you come to HOSHO, we'll make sure that you're following the standard. The versatility of Ethereum, though, allows complex applications to be run on chain, but that is to the detriment of the developer. If you implement bad logic, like I said earlier, smart contracts are impartial. They don't understand the letter of the spirit of the law, they only understand the letter. And so it is only what you implement that's going to execute, and if you implement the wrong logic or the wrong path within your code, it is at your own peril. And I put a couple quotes up here. I had to quote our VP of Products, Stephen Lambert, who is well known for saying the best thing about Ethereum is that it lets you do anything, and the worst thing about Ethereum is that it lets you do anything. Also, Ben Parker, because I'm a Spider-Man fan, with great power comes great responsibility. VeChain, shameless plug that we audited their token, is a fork of Ethereum that extends its virtual machine with a few extra precompiled smart contracts, and that gives some really cool enterprise functionality. They use a split currency system with 2 main currencies, VeChain Thor, which is their day-to-day transactional currency, as well as VeThor. The naming is a little complex at times, but it's very simple. VeChain Thor is your Ethereum. It is your main asset. It is your dollar, or your euro, so to speak. VeChain Thor, though, or VeThor, is only used for transaction fees. And so when you perform a transaction in VeChain or on the VeChain platform, you transact in VeChain Thor, VET, and your gas or your energy cost is paid in VTHO. VTHO is actually an ERC, or I believe they call them VRC on VeChain, VRC20 compliant token. You can transfer it just like you can any ERC20 token on the Ethereum blockchain. It can be traded on exchanges, it can be transferred, you can approve someone to spend it on your behalf. What's interesting and unique, though, about VeChain is that staking VET, holding VET in your wallet, will actually cause VeTho to be minted directly to your wallet. And so holding the main currency will allow you to generate the gas currency or the energy currency and use that going forward. They've also implemented a multi-party payment system, which is great for enterprises. It actually allows you to set a sponsor for your smart contract execution so that your end user is not burdened with the cost of doing business with you. You can say, you know what, you guys are my customers, you guys are my users, I'm going to pay the gas costs for you because I have my own supply of VeThor and I'm willing to spend it to retain your business. This is one of the biggest hurdles on blockchain that VeChain seeks to overcome. It provides basically the same versatility for dApps as Ethereum does due to the fact that it is Ethereum under the hood, but it gives you much more flexibility for many enterprise use cases. Stellar. This is really the first smart asset blockchain that I'm going to talk about today. It's a transaction and options-based smart contract implementation, which basically means that rather than writing code, you are just setting options and setting flags on wallet addresses. There is no difference to Stellar between a wallet and a smart contract. It does not know the difference. If you create a Stellar wallet, you can choose to set options like multi-signature or to transact and set offers on the DEX that's built into Stellar. Oh yeah, they offer a native decentralized exchange on chain. Like I said, this is a smart asset blockchain. They've really built in all the functionality you need to launch an asset or a token right on chain. And this is why I say, why not, if you're launching a token, start looking at some of these smart asset blockchains. If you don't need the extra functionality, this ecosystem has already been built for you. They've built standardized interfaces for common functionality. Multi-signature transactions on Stellar are all handled the same way. Asset transfers are all handled in a uniform manner. And you get the assurance that these functions have already been vetted time and time again, not just by you, but by security auditors that Stellar has engaged, by the community at large. Why reinvent the wheel? Now, this ecosystem is not suitable for complex dApps at all. If you want to implement complex functionality, it must be done off-chain. And that, of course, comes with its own caveats. And that's where you may want to start exploring Ethereum or EOS. Speaking of EOS is yet another Turing-complete smart contract chain. Like I said, they've gotten a bit of bad press recently, but putting that aside, they've actually done some very interesting things. They're not using domain-specific languages like Solidity or Mitchelson or Viper. Instead, they went with languages that are well-known and popular, C and C++. Compiled down to WebAssembly, executed on-chain, and without a virtual machine. It provides you more flexibility than Ethereum or VeChain can, simply because you have the whole C standard library available to you. You are not caught with many of the caveats that Solidity has. They also have a really interesting system by which you can transact in EOS without paying any transaction fees. Similar to VeChain, where they stake gas to your account or mint gas to your account based on you holding VeChain, depending on how much EOS you hold, you get what's called bandwidth to perform transactions on the EOS blockchain, allowing you to perform a limited number of transactions per day based on how much EOS you're holding. I believe the term they're using is proof of importance. Complex dApps are honestly going to do great on EOS if they can ever get past their security problems. But again, the complexity that it allows for demands a ton of additional testing and verification. And finally, NEM. NEM is yet another smart asset blockchain. While they haven't implemented a DEX like Stellar has, they do have the ability to set offers, right? They use mosaics and namespaces to define new assets on the NEM blockchain, through which it is dead simple, honestly, to create a new token, issue it, transact in it. It's honestly all done right in their wallet. You hit a button, say you want to create a new mosaic, fill in a couple of boxes that look just like a web form, and voila, you have your token. If you don't need the additional functionality that's offered by one of the Turing-complete blockchains, this is a very quick and easy way for you to spin up your new blockchain-enabled project or your new token. It has the ability to process a huge number of transactions per second. I think when I looked last, it was 50,000 transactions per second that they were quoting. The whole point of NEM was to allow for rapid resolution of asset transfers. They provide a straightforward platform for tokens, but any other functionality outside of just tokens and assets has to be handled off-chain. There are, of course, other platforms, and there's more even than on this list, but I could go on all day, and I only have a half-an-hour speaking slot. But some up-and-comers that we're very interested in at HOSHO include Tezos, a newcomer to the field using the Mitchelson language, a language which was really built for formal verification. It is meant to make it super easy for your auditing team to come in and say, hey, this is doing what it's supposed to do. I like this. Rootstock, as I mentioned earlier, is a Bitcoin sidechain. Obviously, you get the stability of Bitcoin and kind of the ubiquitousness and the ability to use smart contracts as a sidechain to that. Icon is also an interesting project. You develop in Python. They are billing themselves as the ecosystem of blockchains, and they are trying to allow for atomic swaps cross-chain and to interact with any other isolated chain out there. Finally, WanChain, and I believe they're also here actually, is another Ethereum fork that has enabled cross-chain atomic swaps and have some really cool functionality if you need to move assets from one chain to another. And then obviously there's countless other smart contract blockchains. I'm sure 3 have launched in the time I'm giving my talk. If you want to talk about them anymore, I do have my contact information. Please feel free to reach out to me on Telegram, via email, on LinkedIn, or I'll be at the HOSHO booth both for the rest of the today and tomorrow. And finally, my talk is available for download. I apologize for the HoshoCon link. I didn't update it. But if you go to that link or use the QR code on the screen, you'll be taken right to a page where you can download my talk. Please feel free to reach out if you have any questions. Thank you.
Thank you, Jay.